Hey, and welcome back to Gen Chem with Dr. J. I'm Dr. Janita Pritchett, and in this video, we're going to cover how to name ionic compounds. Let's get started. So, before we get into naming ionic compounds, we need to first understand some basic properties or fundamental things associated with ionic compounds. Remember, in an ionic compound, how that compound is being formed is because we have ions being generated. We have elements that are losing their electrons, like the metals, to create a positive cation. And you have elements that are gaining electrons to take on a negative charge, and those form your anions. Those positive negative ions are attracted to one another to form the compound. Now, when we're dealing with a chemical formula in an ionic compound, our total amount of positives have to equal out to the total amount of negatives. And so we adjust the formula to ensure that we have this overall charge balance of 0. And then when we write the formula, we're going to write it as the simplest whole number ratio of the ions, not all the total number of ions that are present. And so in order to do this, we have to be good at identifying what the preferred charge of an atom would be, and then adjusting the subscripts for the elements to balance out those charges. So we're going to look at those valence groups again, those valence electrons, which is the same as your group element, your group number, excuse me. And so what you would do is you would, again, list your more metallic element first, followed by your less metallic, and you assign the charges. And so notice here, you notice here, aluminum is in group 3, so it has a positive 3 charge. Oxygen has -2. When you look at that, you can see that automatically the charges don't balance out. When I add the two together, I do not get 0. And so we have to adjust that charge. So how to best go about doing that is we first assign the charges and then crisscross down, and you place the number behind the opposite element as the subscript. And so you see the 2 comes down here with aluminum, the 3 comes down here with oxygen. Basically, that's telling me how many atoms do I need to be able to multiply that charge by to balance it out. Now, if you check your math, you can see that, yes, that 2 times 3 does give us positive 3, and 3 times, and this should just be, sorry for the typo, it should just be 3 times -2 or 2 minus, and you get -6 as your overall charge. And so we can see that the charges cancel out. Ultimately, what we want is the overall charge of these atoms to balance out to 0. And so let's predict the formula of the ionic compound that would be formed from these different elements that are shown. So we have sodium, which is group 1. So it would have a positive 1 charge, and chlorine, which is -1. We can see that those charges do balance out, but if you're not sure, you could crisscross down and then write out the formula accordingly. So we would have Na1Cl1, and again, if it's just ones, we would just write it as such. Let's try potassium and oxygen. Potassium has symbol K. It's +1 in group 1. Oxygen, 2 minus, it's in group 6. Crisscross down, and that brings my 2 here and a 1 there. What we would write out is K2O as our formula. Try calcium and oxygen. Calcium is group 2 metal, so we'd have 2+. Oxygen is 2 minus. Now here you may say, yeah, the formulas, those charges, they balance each other out, and you're absolutely correct. But if you weren't sure, you could still bring them down. And then what we end up with is Ca2O2, and we know we can reduce that down even further to CaO. And then last but not least, we have aluminum with a 3+ charge, and nitrogen with a 3- charge. Crisscross those down, and just like above, we would reduce this out to its simplest whole number ratio of the atoms. All right, so once we've identified an ionic compound, our naming system is going to be completely different than what we use for our molecular compounds. So this system that we're going to look at is for binary, meaning 2 elements, ionic, so there's a metal present, compounds, okay? And this system we're going to use is when we're dealing with metals that have a charge associated with them that does not change. It's invariant, it's fixed is what I like to say, a fixed charge, okay? It's set. So these are the elements that every time we encounter this particular element, the charge associated with it will be the same. Now there's a certain group of elements that this applies to, and that is shown for you here. So you're going to want to memorize these. So if you're dealing with somebody, a metal in group 1, group 2, aluminum, which has a +3 charge, zinc, which has a +2, scandium, which is +3, or silver, which is +1. These elements are considered to have fixed or invariant charges, and we're going to name them in a certain manner. The reason we're going to name them, the reason we can do this particular manner is because there's not multiple charges that exist. So I don't have to worry about being able to differentiate to the reader which one I'm talking about. But when we're dealing with something that has a varying charge, we have to add one more piece so that we can tell which element we're talking about. So again, remember group 1, those are going to be always +1. Group 2 are always going to be +2. And then silver is +1, scandium is +3, zinc is +2, and aluminum is +3. When we're naming, again, we're always going to list the metal first, or the cation first. And then we follow it up with the anion, the nonmetal, and add that IDE ending. So make sure here you do not use those prefixes. We're throwing those out the window. That was only for molecular compounds. Here we're just writing the cation, or the metal first, the anion with the IDE ending if you're dealing with an invariant charged metal. We're going to add one thing to this if indeed we're dealing with something that varies. Okay, and so for example, if we have CS, all right, so we first look, cesium is a group 1 metal. It's group 1, so we know it's a fixed charge, so that means I can apply the rules that I am thinking about. So we know that we would first write out that we have the cation and anion present, we have cesium present, and then we also have fluorine, which is present, but we drop the ending, add IDE, and then we would name them as such. So this would just simply be cesium fluoride, not cesium monofluoride, not monocesium monofluoride, not cesium 1 fluoride, just simply cesium fluoride, the cation, the anion plus IDE ending. So let's try this. So we have KCl. Again, we have a metal. We have a group 1 metal, so that means it's fixed. And so we would name the cation, which is potassium, and the anion, which is chlorine, but add the IDE ending, so that becomes chloride. For magnesium, for MgBr2, again, we have a metal, so it's ionic. We have a group 2 metal, so that means that this is a fixed charge. So I would name it as just magnesium bromide. Bromine being the anion. For Al2S3, we have a metal. We have one of our fixed metals, which is that aluminum. And so we would name this as simply aluminum sulfide. Okay, now when we're dealing with any other metal besides group 1, group 2, silver, aluminum, zinc, or scandium, you then are dealing with a metal that can have a variable charge, meaning it has multiple charges that exist. And so we need to indicate what charge of the metal are we dealing with in this particular compound. And so we still do the basics of what we did in the fixed example, where we list the metal or the cation first, and we list the nonmetal or the anion with the IDE ending. But now we're going to add a charge here in Roman numerals that reflects the charge of the metal. And so what that means is if you don't know that charge, you have to first determine the charge through a little bit of algebra before you're able to name this. And so again, this is telling us the charge of the metal. And that's always put into Roman numerals. All right, so for example here, if we look at Au2S3, we see that we have a metal, Au or gold, but we also know that it's not one of our fixed metals. It's not in that one of those categories that we listed. And so what I have to do is I have to first figure out what is the charge of the metal here, the cation. Well, fortunately, in these problems, you'll know or be able to determine the charge of the nonmetal. Look at the group number. What group is it found in? Sulfur is group 6, which means that it would take on a -2 charge. It's going to add on 2 electrons. And so we could say it's 2 minus. And so just like we had crisscrossed down in a previous chapter, we can crisscross back up to figure it out what the charge would be of the metal. And so we can see that charge at 2 is present, so I know I can easily crisscross back. And so that means to balance out this charge, this gold must be a positive 3 charge. And so when we're naming it, we need to reflect that positive 3 in the name because multiple types of gold charges can exist. And so when we name this, this would end up being gold 3 in Roman numerals sulfide. Okay, so let's try finding the charges in this particular problem. So we have titanium and chlorine. Again, titanium is a metal. I don't know its charge. I know that chlorine is found in group 7. Group 7 takes on a -1 charge. And so if chlorine is that -1, then that means to balance it out, that pass it back up, this has to be a 4 positive charge. Okay. For chromium and oxygen in this case, well, we know oxygen is in group 6 and it likes to take on that -2 charge. Now, what you should see in this example is that I don't see a 2 there that I could have worked my way back, right? And that's because that 2 has been reduced out. This is shown to us in an empirical formula. And so the crossback method will work 90% of the time, 99% of the time, but you have to be aware of if the subscript has been reduced down because of some common number. So that's where you have to go with what you know versus what you see. I don't see a 2 there, but I know oxygen is a 2 minus charge based on where it's positioned. So if oxygen is 2 negative and I have 3 of them, that means chromium has to be positive 6 to balance it out. And so you can see when we back check ourselves, so 6 plus -2 times 3, that does indeed give me 0. So that checks out. So that's always a quick way you can verify your answer. And then last but not least, we have Fe3 and 2. So nitrogen's group 5, and so that would be a 3 minus charge. And then iron, which is is one that we don't know. Based off of crossing it back and balancing out that algebra, this has to be a positive 2 charge. Again, before you can try to name something, an ionic compound with a varying metal, you have to figure out the charge. So in this example here, we have CuF2. So again, we have fluorine, which is group 7. We know it takes on a -1 charge. I don't see, I see a 1 there, so I could cross back, and to balance this out, I know copper should take on this 2 positive charge. And so that means that when we name this, this would be copper 2. So put it all together, we would write copper 2 fluoride. Be careful on a test, you don't want to write this because that is not properly showing the charge. The charge has to be in Roman numerals. You also want to be careful, especially if it's a multiple choice test. Very likely they would have something like copper difluoride, trying to trick you up. So just make sure that you go through that series of questions. Is it a molecular ionic compound? If you say it's ionic, does my metal have a fixed or varying charge? And that'll help you tease out which way you should be doing your naming. So let's put that all together. In the previous problem, we saw that in this case, titanium was 4+ and chlorine is 1 negative. And so when we name this, this will become titanium 4 chloride. Again, the IDE ending indicating that it's a compound. Okay, the next one, PbBr2. Well, we know bromine is a group 7, so that'd be 1 negative. Lead is unknown, but we can do algebra to figure out that it would be a 2+, crisscross back. And so when we name this, this would be lead 2 bromide. This would be lead 2 bromide. And then last but not least, we have Fe2S3. Sulfur is in group 6, so that would be 2-. We see that 2 is there, so that means I can crisscross back. So this would become 3+. And so we would write this as iron 3 sulfide. And so, of course, just like before, if we can go from the formula to the name, we can also go from the name to the formula. So in this case, if we have manganese 4 sulfide, I already see some clues to tell me what kind of compound this is. I see no prefixes, so that tells me, okay, I'm probably dealing with an ionic compound. I also see Roman numerals, so that tells me that I'm dealing with a metal that has a varying charge. And so we would take the elements and first assign their charges. And so you would see you have Mn and you have sulfur. And then we assign the charges. We crisscross down. So that becomes Mn2S4, and we check to see if it can be reduced. If it can be reduced, as in this case where you see that I have a common number between the two, we then would end up reducing it down to its final form of MnS2. And to check out your math, you can check to see, does it add up indeed to balance out my positive and negatives? And in this case, it does. Okay, so let's put that together. We have copper 2 ion with a nitride ion. So copper 2 is telling us we have Cu with a positive 2 charge. The nitride ion, N, nitrogen is in group 5, so that would be -3. And then iron 3 ion, which would be F. And then after we've assigned those charges, we then crisscross down and write the final formula. For the following one, iron 3, we have Fe, 3+. With the bromide ion, bromine. Notice again for the anion, it's not telling me the charge, so you have to look on the periodic table for that. So bromine's group 7 would be -1 or -1. When we cross down, what we end up with is a 1 and a 3 here. Final formula would be FeBr3, and you notice again, we cannot reduce, so that would be the final formula. So we're gonna add one more layer into this ionic compound naming system, and that are these things called polyatomic ions. So polyatomic ions, if we break that word down, poly, so it means many, atomic, so many atoms that are together, ion, so many atoms that are together that have a charge. And so these polyatomic ions have a set formula associated with them and a set charge. And so when we're naming them, we're going to be incorporating them in as either the anion portion of your naming system, or in one specific case as the cation portion. But everything else remains the same, how we go about assigning charges and crossing down accordingly. Okay, and similarly, we would still name the cation first, followed by the anion. So I'm going to leave this chart up for a second. Definitely take a picture of it. I really suggest making flashcards for how to learn these polyatomic ions. These are ions that are going to be heard, and you're going to see them throughout the entire course. So it really pays yourself well if you actually do your due diligence and get these memorized. I recommend get a flashcard, and on the front, write the name. On the back, write the formula along with the charge, because that piece is very important for the naming system. And so on this chart, I want you to go ahead and add one more to this chart, which is phosphate. That's another common one you see in here. So that's PO4 3-. Okay. And so again, what you can see in this particular chart is that there are a lot of things that have some similarities. Like for instance, if you look at nitrate and nitrite versus chlorite and chlorate, and sulfate and sulfite. The thing you should see when you see ates versus ites in a formula is that the ates always have one more oxygen than the ites. Now, just because you have an 8 as the ending does not mean it's going to end with 3, because you can see like sulfate ends with 4. But what you can see is that when I compare within a series, sulfate to sulfite, there's only a difference of 1 oxygen. So that should help you with memorizing, because if you memorize one, you default know the other one. Okay, and so we're going to show you how we work these into your naming system. And so when you're naming compounds with a polyatomic ion, well, first you'll recognize you likely have a polyatomic ion if there's more than 2 elements. All the previous examples were binary ionic compounds, so there were only 2 elements present. But in this case here, I see a total of 3 elements present. So you have to identify, okay, well, what polyatomic ion do I have here? And so I see SO4, And SO4 is our sulfate. And we know sulfate has that 2 negative charge. That is our anion. I also see I have sodium, which is a fixed group 1 metal, which is +1. And so when we're naming this, we would still just name the cation, which is sodium, followed by the anion, sulfate. We don't need to say sodium 1 because sodium is one of our fixed charged metals. If we're dealing with a metal that has multiple charges, it's the same thing. We still just go through the process of identifying what polyatomic is there and what's the charge of the metal. So when I see this, I have this invariant charge, I have a varying charged metal, iron, and I have nitrate, NO3. Nitrate as a whole, as a polyatomic ion, has a -1 charge. Well, if I have 3 of them, that 3 outside of the parentheses tells me there's 3 of that entire unit, 3 of those. Well, then to balance this out, this must be 3 positive to balance it out. And so when we name this, this would be iron 3 nitrate. Again, this 3, we're just simply crossing back. Okay, so let's put all that together and try naming some compounds with polyatomic ions. So here we have NH4Cl. Now, if you remember early on, I told you that with ionic compounds, primarily 99.9% of the time, you're gonna have a metal present. Well, this is actually an example where no metal is present, but you still have an ionic compound. And so what we see here is what we have is NH4, which is a cation, ammonium, that's one of our polyatomic ions, and then the chlorine ion. So despite no metal being present, we're still going to treat this as an ionic compound. And so then when we think of that, how do we treat that cation? Does it have a fixed charge? Well, yes, it does, because anytime we say NH4, it's the +1 charge. And so when we name this, we're going to simply just list the cation, which is ammonium, followed by the anion, which is chlorine, and then we add the ID ending, so that becomes chloride. So that would become chloride, ammonium chloride. For CaC2H3O2, again, go through the process. We have a metal, so this is ionic. We have a fixed charge, group 2, and so we list the cation and then the anion. So this would be calcium. Again, I don't have to say calcium 2 because calcium is always +2. So calcium acetate. And then last but not least, we have CuNO3 We have a metal. We have a varying charge. So we have to first figure out its charge. The polyatomic ion present here, that's nitrate, which has an overall -1 charge. If I have -1 of those for that nitrate, but there's 2 of them, to balance this out, that means copper must be +2. And so we would name this as copper 2, in Roman numerals, in parentheses, nitrate. And then similarly, we can, just like before, go from the name to the formula based off what we see. So it says iron 3 phosphate. So again, we know we have an ionic compound. We have a metal that can take on multiple charges. I have a polyatomic ion present. So we got to take all that into account. So iron 3 would be Fe with a +3 charge. Phosphate, PO4, 3 negative charge. We then assign or crisscross down and assign charges, or assign the subscript, excuse me. So this would become Fe3, PO4. And make sure when you add this 3, you don't just do that, because that makes it 43. We need to actually put it outside of the oxygen as such. And then we reduce down if capable. And so that would become Fe3. That would become FePO4. And that would be our final charge. And again, you can see that the sum of the total charges still equals out to 0. Okay, last little bit before we conclude this video, we have the aluminum ion and sulfate ion. So aluminum is +3. Again, we know that from it being that fixed charge. Sulfate is SO4 with that 2 negative charge. We cross down, so that would become Al2. Put parentheses around the sulfate, add the 3. So when we write that out, we have Al2, SO4, like so. And then last but not least, we have chromium 2, so Cr2 plus, and then hydrogen carbonate, which is HCO3 minus. We cross the subscript, so 1 and 2, and then we write our final formula, which in this case would be CrHCO3 2. I hope this video helped you learn how to name ionic compounds. Be sure to like, comment, and subscribe, and tune in for more videos. Have a great day, and I'll see you in the next video. Bye.